Okay, where's my recording button? Okay, good. So let's get started now. Today we are actually doing correlation and regression. Okay, so the idea of correlation is, let's say correlation is to find out whether two variables, okay, in this case we talk about the x and the y, moves together. Okay, so meaning to say that if x increases, y increases also. So this is what we call as a positive correlation. Okay. So if x increases but y decreases, then we call this as a negative correlation. Okay. Sometimes this is also known as your inverse correlation. Okay. So far, any problem with this? Should not. Any problem? Hello. How to differentiate between positive and negative correlation? All right. Is there anybody around?
Yes.
Okay, good. So the most common correlation that we use is this thing known as your Pearson's correlation. Okay, Pearson's correlation has a very long name, but let's call it just Pearson's correlation. The symbol is R. Okay. Is there a lower and upper limit for R? Anyone? If there is, what's upper and lower limit? Danson, any upper and lower limit? Hello, are you still eating, sleeping? Jane? Can you hear me? Jane? Lawrence?
Yeah.
Yeah, is there upper and lower limit for R, for correlation coefficient?
-1 and 1.
-1 and 1, correct. So correlation is actually bounded by -1 and 1 inclusive. Okay. All right, so the whole idea is, let's say the absolute R value. The absolute R value closer to 1 means that the data points is tighter or closer to the best fit line. Okay, you have learned how to draw best fit line back in your secondary school days already, but today we are going to learn something different. Okay, so that's the main purpose of correlation coefficient, is to see how well, so meaning to say that correlation is to see how well two variables, so-called, move together. Right? So that's the whole concept of it. Now, the equation for Pearson's correlation is actually a bit long, but it's something that you keep seeing. So this is the equation for Pearson's correlation. Oops. All right. Okay, then there's actually another thing that you always see in Excel. The Excel always give you this thing called R square, or sometimes it's small capital R square. So R square is essentially just R times R. Pearson's correlation times Pearson's correlation. Now, what R square is actually not really correlation, but it's called by a different name, called coefficient of determination. Okay, so this name, coefficient of determination, you should have some idea what it is. So why do we have this thing called R square? So let me give you an example. If let's say you do something in your lab and you want to measure, let's say the albumin concentration, albumin concentration versus your OD280, the spectral reading. So you are actually trying to do a standard curve. I think you've done this experiment before. Okay, so what you prepare is serial dilutions of your albumin, and then you do a burette test or Lorry test. So take stock albumin, then you do dilutions. Okay, then after that you do a burette test, okay, or Lorry test. So what you end up with is you end up with a table, your albumin concentration, and then the OD280 reading. Okay, so you have different concentrations. You take this result and you actually plot a graph. Okay. Your graph will be OD600, OD280. I always use 600. OD280 and your albumin concentration. Okay. So you end up with here, 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 and so on. Then you draw a best fit line. Okay. So you draw a best fit line, you can calculate R square. Let's say the R square, let's just start with R first. If the R is, let's say, 0.9, which is actually pretty good, what will be the R square? If R is 0.9, what is R square? Quickly, Lawrence? Lawrence! Ong.
Hello?
Yeah,
R square?
yeah. R is 0.9, is R square.
Is it 0.81?
Correct, correct. So 0.81. Okay. So if the R square is 0.81, it simply means that this also means that it is 81%. What does this really means is 81% of the variation of your Y, which is the OD 26280, can be explained by X, which is the albumin concentration. Okay, that means why the OD increases, 81% can be explained by albumin concentration, which also means that you have 19% of the of the variation of OD 260 is unexplained. Okay. By unexplained, it means that you can have dilution error, pipetting error, and so on, etc. All these accounts for 19% of all the errors. That's why when we want to get R square as high as possible, if one person, if one group, let's say Jen's group do this experiment and your R square value is 0.95, that means 95% is explained. 5% can be all the other errors. And the other group, let's say you get only 0.9. Okay, so obviously the higher the R square, the better it is. So that is the concept of the whole thing. Okay. So then we actually have this problem. This thing called, we want to find the best fit line. Okay. So to find the best fit line, back in your secondary school days, in fact, primary set 1, or you actually learn how to do a best fit line, Y and X. Let's say you do a physics experiment. Okay. Okay. Let's say for this, how do you find the best fit line? Let's say in your secondary school, what is the method you use? Ifa, what's the method you use?
I just make sure the points like there's the equal number of points in between both lines.
Okay. Is it just equal number of points? Yeah, equal number of points, the first one.
The distance is also like similar.
Right. So the distance between the points and the line. Okay. So essentially, what you have said is actually the correct thing. Best fit line, there could be many other. For example, is this the best fit line? Is this the best fit line? Okay. We actually do not know. So there can be many best fit line, but is there a mathematical way of finding what is the best fit line? Okay. It's actually using what Eva mentioned. This is the criteria. So if we look at this criteria and we exemplified it, how does it really look like? So I'm just going to roughly redraw the whole thing around there. Okay. So my best fit line, number one is that there must be equal points up and down. Okay. The second is the distance. Let me use a different color. The distance between the points should be more or less equal. Okay. And if we call this the distance as E, the error. So how do you find the best fit line? Essentially, if this distance are E, what you are really trying to say is the summation of all the positive E, those that's on top, minus the summation of all the negative E, those at the bottom, should be equals to 0. This is what the distance really means. And sometimes we call this method as the least square method. Why is it called the least square method? Going from this, essentially, what we are actually saying is, if you're actually trying to say that Okay, let me just erase it. So if we take all the E, whether it's positive or negative, we square it and we sum it. What we are trying to find is what is, so here we y equals mx plus c. What is the what are the values of m and c so that this the error square is the minimum. It's the lowest. Which means that we are actually playing with all the different intercept and gradient just to make E to be the minimum. Okay, if you do it in a calculus way, it will be this. Close to 0 as possible. Okay, then that is what least square line actually means. So with that, there are equations to help us. Okay, so let me just, okay. Now what you have is y equals to mx plus c. Okay, in statistics, we tend to write it as y equals to b1x plus b0, or beta 1 and beta 0. But in your calculator, you will see it as y equals to bx plus a. This is where your calculator is. Okay, so this is the same. This means the same thing.
Wait, Jack, can I ask a question?
What?
You know the best fit line that you draw just now, right? The best fit line that you drew just now, the coordinates, right? The one with the smallest coordinates and the largest coordinate, right? Must they like link to each other?
No. There's the one largest coordinate don't link to each other.
So like in order for me to draw a best fit line, that property don't exist, right?
Property don't exist, correct.
Okay.
Our purpose is then to find out what is B, what is the value for A. So that is what we want to find out. We want to find out what is the value for A and B so that this number is minimum. Okay. And the equation for doing this is actually quite standard. In your calculator, you put everything correctly. B is actually calculated by this equation. Okay, so you solve for B, and once you solve for B, the next step is to fit B into this equation. Average of y equals to B times average of x plus A. So then you solve for it, it will be A equals to average of y minus B and average of x. So this is where you get your answers. Where's my B? B is my green, so this B, and then you put the B into here, you put the B into here, and this is where you get your A. So solve here and solve here. Okay. After that, the whole thing you fit back into your equations. So far so good? Now, if you realize we keep seeing this guy here. Okay, we keep seeing this thing all the time. So actually, I want you to go and think about it whether you this is out your syllabus. Is there a relationship between your correlation, which is your R, and your regression, okay, which is calculating your A and B? Do you think there's a relationship? Okay. Given that, rewrite the equation here. Oops, wrong. And here. Do you think there's a relationship? See this, the numerator is identical. And the denominator looks somewhat similar as well. See the denominator? Do you think there's a relationship? Yes, no? Somebody just make a guess.
I think have.
Oh, who are you first? I don't see your name. It's hard to recognize your voice.
Oh, I'm Jen.
Jen, okay. Yeah, there is a relationship, correct. So, yes. Oops, big fat one. So, yes, there is a relationship. Okay. And then my final question is there a relationship between your standard deviation, which is S, and your regression, which is then, okay, I won't say regression. I will just we just deal with correlation. Okay. Correlation. Remember your standard deviation is this. And this is where you see this part popping up again. So do you think there's a relationship? Somebody other than Jen? Ishana? Are you around? Okay, who else is around? Vivian? Okay, who? Gerard's Wi-Fi needs to be rebooting. He's off for 10 minutes. Okay, fine. Vivian? So is there a relationship?
I think yes.
Yes, yeah, there is a relationship. Okay. Okay. So I will not put everything together. In fact, I've before that, let me just state one more item, which is quite important. So the purpose of regression is to find the equation linking x and y. So this is critical. Black. What color have I not used? Blue, purple. So the purpose of regression is equation. Okay.
Sure. What's the point if there is a relationship between the standard deviation and the
This is just to show you what you have done in the past, what you have studied in the past of standard deviation is actually used here. Because remember, when we talk about correlation, we talk about how well the line, the data points fit, is how well the data points is, how close they are to the best fit line, right? Correct?
yeah.
Okay. So if the data points is close to the best fit line, will that also mean that the standard deviation is also smaller compared to if the data points is far apart from the best fit line?
Yeah.
That's a relationship, huh?
Okay.
Okay. So let me just show you. I will put this on because the maths is a little bit more complex, so I will not show you the maths here. Okay, I save it. Okay, so let me just show you. I've actually written down, I'll put it in the slides at the end of it so that you can go and see where on earth is my slide. Here. B1 and B2. Here. Yeah. So I'll put this in the PowerPoint. So actually this is the relationship. Kind of solve the whole thing for you. So I go from your Pearson's correlation to standard deviation and then how I substitute into it. So you end up with your standard deviation. Then from your linear regression, you actually end up with your standard deviation and correlation. Okay, so I will not bother about this here. Okay, so with that, we can actually do our tutorial now. And tutorial, there's a lot of true-false questions. So let's try. Okay, so let's start with question 1, our true-false question. If you run a least square line on a data set to obtain a particular regression line, and suppose you add another observation and run a new least square regression, the regression line will definitely be different. True or false? Let's see. Oops, what I'm doing. Yeah, I'm here. Right. Down. Get out. Where am I with your? Let's see who wants to answer. Rachel? 1A, true or false?
False.
False. Why? Why the regression line can be the same? Yeah, it's false, but why?
Not sure.
Not sure. Okay, because you see, you add another observation. If the observation happen to be on the best fit line, exactly on the best fit line, then it doesn't change. Okay, so that's the reason. So the correct answer is false. So this is false. So I'll write here, if the added data point is on the best fit line, the equation will not change. Okay, question 2. If Pearson's product moment correlation coefficient, that's a full name for Pearson's correlation, of a data set equals to 1, then Spearman correlation also equals to 1. True or false? Okay, I'm running out of people. Okay, sure. I'm back. Okay. Gerard, true or false?
This one not very sure. I think false.
False. Actually, it's true. It's true. Huh?
Oh.
Okay. Yeah. You realize that Spearman correlation is always higher than Pearson's correlation. Okay. Okay. Question C. If the sign of the Pearson's correlation of a data set is negative, then the slope will be negative. True or false? The slope, that means a gradient. Let's try another person. Hello. Okay, who is this guy? Ziray.
For C, right?
Yeah, correct.
I put true.
True. Yeah, it's correct. True. Okay, for D, homoidacity is a term for linearity of error points for all the values of X. Let's have Shenwei. Shenhui, are you there? Hello? Okay, next. Who is this person? Faith. True or false? 1D. And, yeah. False, correct. So homoidacity means equal variance. Okay, it's false. This term homoidacity means equal variance. Heteroidacity means unequal variance. Okay. 1E, linear regression is always appropriate when you have two variables measured on ratio scale. True or false? Okay. Is this? Okay, anyway. And?
Is it true?
No, it's false. Okay. So it's not always appropriate. For the reason you actually have to look at the scatter plot, because it may not be a straight line. Okay, it may not be a straight line. So you have to be careful of that. Okay. Question 2 is also okay, which one has coefficient of -1? So this is pretty easy. Mainly.
Hi, is it
Hi.
B?
B, correct. Yes, it's B. Okay. Pen. Okay, so it's B. Okay. Question 3. Okay. So 3, which one? Can you use Pearson's correlation, Spearman correlation, or both? Okay. Do people with higher education level have a stronger opinion whether whether or not tax reforms are needed? Okay, so Avina?
I put Spearman rank correlation.
Correct. So it is Spearman. Okay. Where you use Spearman is because opinions is actually a ordinal scale. When you have ordinal scale, it's very hard to use Pearson's correlation. Okay. So that's the main context. B. So we have Faith already, we have Gerard already. Junyang?
Is it Pearson?
It's not Pearson, it's just Spearman. Okay. Because willingness is not a, okay. You can only use Pearson's correlation if both data points, if both X and Y are both normally distributed and are at least interval data. Okay. So willingness is not interval data. Willingness is more of an ordinal data. Okay. Now, this question is actually quite tricky because there's actually a lot of assumptions for Pearson's correlation. That's why it is stronger in a sense. Okay, so C, Ishana, come back to you again.
Is it Pearson's relation?
I think it's Spearman. Okay. Are customers more satisfied? So satisfaction and quality, they are ordinal data. Okay. So you realize that actually a lot of them, by right, you cannot use Pearson's correlation, just that we use them blindly. Okay. So D. During circuit breaker in Singapore, does the number of household members correlate with the number of food takeaways? Remember, think about number of household. Is it normally distributed? And is the number of food takeaways normally distributed? Okay, Joey.
Sorry, can you repeat your question?
My question is D. My question is D. Yeah. Just now I read E. So are the letter grades in reading and writing correlated?
Yes.
No. It's not yes. Which one should you use? Pearson's correlation, Spearman correlation, or both?
Oh, sorry. I think Pearson.
No, it's Spearman again because letter grades and writing grade, basically letter grades are not normally distributed. Okay, so
Okay.
in fact most of the time we use Spearman by right, just that we, again I say blindly, we use Pearson's correlation. Okay, both E and F is actually you can use for both. Okay, you can use for both. All right, so question 4. Which of the following trends do not represent monotonic function? Now, what am I doing? Question 4. Okay, we have Jane. Jane, are you there? Marcus?
D.
Yeah, D. Okay, good. Okay, Marcus, you are prepare yourself for next one, huh? Okay, question 5. A teacher investigates how running speed is related to their age. So age versus running timing. So let's say question 5 now. Huh? So what you're using is your y equals to mx plus c. Okay. And what you are trying to find is the correlation. So part A, what is the correlation? Marcus. Marcus, where are you? Marcus is sleeping already. Nadia?
R equals to negative 0.912.
Yeah. Okay, correct. Okay, so part B, if you actually use another model, y equals to m over x plus c. Okay, that means what you're trying to do is take the x and y value and transform it into, you're using your 1 over x reciprocal of x as though it is the x value. Okay, so what is the correlation? Gerard, Shana, okay, we have all these done already. Lawrence, Nikesh.
Hello, yeah.
Yeah. So what is the Pearson's correlation for answer B? 5B.
I'm not sure.
Okay, so what you do, right, is that originally you have the timing, let's say timing. So H is actually the X variable, okay? Then you have all these numbers. So timing is the Y variable. So just now what you have done for part A is you are using this to calculate for part A. So to calculate for part B, what you need is to take the reciprocal of X 1 over H, which is 1 over X. Okay, and then you use these data and this data to calculate for here. Okay. So for example, originally your age is 5 years old. Now here you have to take 1 over 5 and then so on. Hey, what am I doing? No. I just messed up myself, but let me see if I can erase this. This is even worse to erase. Okay, not this. Okay. Yeah, now I know why I do this. Okay, let me just okay, let me repeat all over again. So what we have is this data set. Okay, originally we have age, which is the X variable. Okay, and timing, which is the Y variable. So let's say this is 5, or let me just do a few. 5, 6, 7, 8, and so on. Okay, so here is 98, 85, 73, 69, and so on. So for part 1, part A, I'm actually taking these values and I'm using it as X and Y values for here. For part 2, I actually have to take 1 over H. So this 1 over X and use as though it is X. So here is 1 over 5, 1 over 6, 1 over 7, 1 over 8. And I have to take these values to calculate for here. So your answer should be 0.992. So part C, which model is better? Model A or model B? So this is model A, this is model A, this is model B. Which model is better? Xuening?
The second one.
One, correct. So second model is better. And why is it better?
The R value is closer to 1.
Okay, as the absolute R value, it is closer to 1. You cannot say R value is closer to 1 because this is negative. Okay, its absolute R value is closer to 1. Okay. So does a scatter plot actually shows that? Okay, so it's actually yes, the scatter plot shows better linearity. Okay, so that's your answer. 2, 5. Okay, 2 more. Okay, question 6. Okay, question 6, your data set. Part A, the model that you use is y equals to bx plus a, and ask you for the correlation. Okay, seems like we have used up all the people. Grace, not yet.
Yes.
Yes, so what's the correlation? What's the correlation for 6A?
0.632.
632, correct. So since you're there, might as well you answer for B as well. So what's the correlation for y equals bx squared plus a? Yeah, Grace, what's the answer for B?
I'm not sure.
Okay, so same thing. You do what we have just now. Instead of x, you actually change all the x value to x square value and use it as x. Okay. So let's have n. So for 6b, what's your answer?
For question what?
For question 6b.
Oh, wait. I haven't calculated yet.
Okay, who has calculated? Let me give me an answer. Anyone want to help out? Anyone? Quick. Anyone calculated? Quick, anyone? So these are kind of common questions that we always ask in tests. Evina, have you done it?
I'm so sorry. I don't know how to do the question 6. I'm so sorry.
Okay, so which part do you not know? Which part do you not know how to do?
Like when the day I did, I just don't know how to do. I only did until question 5D. Like I stopped there.
Okay. Who has done question 6? Who's done question 6?
Is the answer 0.767?
Seven.
Oh yeah.
0.77 what?
767.
Almost there is 0.794. So probably one of them you never square properly.
Okay.
Okay. So part C, so which model is better based on this? Model A or model B? So N, since you're there, model A or model B?
Model B.
Yeah, model B is better. It's better. And then what you have is you are looking at what is the A and B coefficients. So here should be about A is minus 92.1, B is about 1.78. Then question D, you actually use model B. So model B, y equals to 1.78 x squared minus 92.1. And what you are asking for, question D is when temperature is minus 10 degrees Celsius. Okay. What is the volume? So temperature is your x variable. What is the volume? Which is the y variable. So what you do is, what is y when 1.78? The x value is 10 square minus 92.1. So y, the volume is 85.9 centimeters cube. Okay, but is it reliable or not? Is it reliable? Is this answer reliable? Okay, based on what you see, Faith, is the answer reliable? Faith, are you there?
Yeah, but I'm
Yeah.
not very sure.
Okay. The answer is it's not reliable. Okay. Why is it not reliable? Because the absolute R value is lower than 0.9. Okay, this is something that I want to point out. For the purpose of this module, we actually say that only for purpose of this module, we say that only when R is more than or equals to 0.9, then the model is reliable. Okay, for this module only. In experiments in biology, you almost never get 0.9. Okay, so don't be surprised. Okay. Okay. Also, I want to say that what makes a model is only reliable only when these two conditions are met. Number one is R square, the absolute R is more than or equals to 0.9, and second, it is a interpolation. The data cannot be extrapolated. Okay. All right. Question E. Question E says that actually the person who recorded data made a mistake. There's an abnormal observation. So is there an outlier? Look at the scatter plot. Is there an outlier? Just now who answer? Let's see. Gerard, is there an outlier?
Hi. So it's question 7, right?
No, it's question 6E.
Oh, 6E.
Yeah.
Yeah, the one at point 20.
Okay, so the point 20, yeah, 900 is the outlier. Okay. Okay. So if you remove the outlier and you recalculate again, the R square is about 0.989 for model A. So actually model A is better in that sense. Because of this outlier, it makes it worse. This actually tells you that when you do any experiment, rather than just calculating the correlation and the regression line, you always have to look at the scatter plot. Because scatter plot can tell you a lot of things. Whether our data are collected correctly or wrongly. Okay, question 7, last one. Okay, accountant of a company monitors the number of items produced by the company in $1,000, together with the production cost also in $1,000, shows 12 sets. Okay. Now, what you want to do is question 7, part A. Is there any outlier? Okay, Junyang. Is there any outlier?
I don't think so.
Okay, correct. No outlier. Okay. So B, you are asked to put everything into this equation. So production cost. Okay, let me see. Just this. So y equals to bx plus a. So y is your production cost, because in terms of thousands of dollars. X is the number of items, also in the thousands. Okay. So what is A, what is B, and what is the correlation coefficient? Okay, Ishana, you haven't spoke today. Where on earth is Keith? Yes, he is missing. Ishana, are you there?
Hi, yeah.
Okay, what is A, what is B, what is A, what is B, and what is R for this?
B is 20.985.
No, that is A, not B.
Eh? Oh, sorry.
20.985, correct?
My bad, sorry.
Get the one?
Then B is 0.978.
9788, okay.
Yeah,
Correlation.
R 0.998.
All right. Okay, what happened to Keith, huh? Where on earth is he today? Okay, so question C. Based on the R value and scatter plot, comment on the relationship. So comment on relationship. When you comment on the relationship, you have to use these terms. Okay, how to comment on relationship? Okay, I give you a choice to pick. The first set of words that you have to use is whether is it strong or weak. Second set of words to use is positive or negative. The third set of words to use is linear or non-linear. So in this case, we say that there is a strong, positive, and linear relationship between production cost and the number of items produced. Okay, so these are the words that you have: strong, positive, linear. Okay, what do I mean? Strong is when the R, absolute R is more than or equals to 0.9. Okay, positive is when R is more than 0. Linear is basically a straight line. Okay, part D. Using your regression, estimate the cost of production for 70,000 items. Okay, so 70,000 items. What is the production cost? Okay, so how much? Now, Jen?
6,000. 68480.95.
68480.95. How come?
Huh? Oh. I suck in the value of x into the equation there.
Okay, so you're supposed to be y equals to 0.9788 of your x plus 20.985, correct?
Yeah.
So 0.9788, what is x for you?
70,000, right?
No! Remember the x here is 7.
Oh my god! Okay.
Yeah, copy again.
Huh? Okay, I never even calculated. Okay, wait. Is it 89.445
0.45 what unit?
dollar?
No, in
Oh.
thousand, so 89.
Oh wait.
$5, $89,000.
Oh, okay. 89, yeah, $1,000. Yeah, okay.
Yeah, okay. So all these are, please be careful. Okay, so is it reliable or not? So yeah, Jen, answer. Is it reliable or not? Is the answer reliable?
I think it is not. Wait, it is.
Why? Why is reliable? Or why
I
is
don't
not
know.
reliable?
I don't know. I guess one.
You guess.
Sorry.
It's reliable because one, R square is more than 0.9. Okay, here, R square is more than 0.9. Second, it is a interpolation. Interpolation simply means that you look at the data point, is it within the range? So 70,000 items, look at the table given to you, right? The lowest is 15,000 items all the way to 81,000 items. So it's within the range. You cannot extrapolate out of the range. Okay, that's why it's called interpolation. It's reliable. Okay. E. Let's say the selling price of each item is $2.20. What is the minimum number that you need to produce before so that the company doesn't suffer a loss? This is a bit tricky. Just give me the answer first and see if it's correct, then correct or wrong, I'll show you. So Joey, what is the answer that you have? Minimum number of items. Are you there? Vivian?
17173.
17173, correct. It's 17173 items. Okay, why? So if let's say this is the production cost, so y is the cost of 0.9778x plus 20.985. So you need to produce the same item. So the cost is actually you want the selling price is 2.20 times x. It has to be more than equals to the production cost, 0.9778x plus 20.985. So you calculate x is actually more than or equals to 17.1726 thousand. Therefore, you need at least 17173 items. So that's the answer. Okay, come to the end of the tutorial. So any questions so far? Okay.
Yeah,
Otherwise,
real world.
what?
Real world applications, what is a good R value?
What is a good R value? It depends on which field of study or field of work you are dealing with.
Okay, let's say medicine.
Medicine.
Like doing some kind of cosmetic cream that will cure pimples.
Maybe 0.5, 0.4.
What?
Yeah.
That's less than half leh.
Yes. In fact, right, if you, for example, when I do genetic studies, right? Genetics, okay. Our value is about 0.4. This as best, almost as good as you can get already, about 0.4, 0.5.
Okay, I see.
Yeah, it's just like, okay, so Gerard, how much food you eat? Do you think you eat a lot of food or eat little food?
Small eater.
You eat little food, okay. So how many of you, you have friends who eat a lot and never get fat?
I have one, but he
Yeah.
exercises a lot.
Or the other set of people who eats little and get fat all the time. So humans, biology, I'm trying to say is biology is very unreliable. Okay. So when you are, let's say, for males with above 35 years old, when the testosterone starts to drop, you can get fat just drinking water. So that's a problem. Hello? So biology is unreliable. So how do you get a good correlation? It's very hard to find good correlation. Okay, if you're doing cosmetics, it's actually even worse because it's the skin. There are people whereby, okay, if you want to do cosmetics, for example, let's say there's a lot of variables that you cannot control. What is the cosmetics simply means that you want to make yourself younger and so on, right? What is the best cosmetics actually? Any guess? What's the best cosmetics?
Sleep.
Sleep, yeah, sleep is actually one of the best cosmetics available. So, when I burn a lot of midnight during the days where I burn a lot of midnight oil, right? There are actually advertisement on TV, those advertisement that try to sell moisturizer, sell cosmetics, and the advertisement is like 4 a.m. in the morning. If a person doesn't sleep at 4 a.m. in the morning, no matter how much moisturizer you put him or herself, it's actually not going to work very well. So if your test samples are those that refuse to sleep, it's not going to work as well, and so on. So you can't control all this stuff. Okay?
Okay, I understand now.
Okay. Any other questions? All right.
Richard, I got a question.
Yeah.
Cause the lecturer say cause and effect. No, you go and say correlation got no cause and effect relationship, right?
Yeah.
But then I don't know why.
Yes, there's no cause. Very important. This is the point I forget just now. Correlation doesn't mean causation. I must just write now. So this is so important that I may just have one slide just to do that. Okay. Red. Okay. Correlation is not equals to causation. When something is correlated, it does not mean that the X causes Y or Y causes X. Okay, this is a very important point because actually anything is correlatable. Anything can be correlated. Okay, this is a very important thing. Thank you. I forgot to explain to you. All right. So let us just take a few cases. For example, let's say in the situation whereby, do you ask your parents where you come from? Do you ask your how many of you actually ever ask your parents where do you come from? Hello? And what do your parents tell you? Gerard, do you ask your parents where do you come from? Or they? Okay. So
Yeah, got ask.
Okay, then what your mother or father say?
They say I come from interactions.
Interaction.
Like they interact lor.
Interact law. So basically, then they try to tell you, but without telling you the thing lah. How many of you? Yeah. How many of you, when you ask your parents, you actually came from the market or came from a dustbin? Anyone?
They say I come from dustbin because I don't eat fast food.
Oh, okay. But most of the time, your parents say that you come from a dustbin or come from market. Basically, they do not want to explain to you the whole process of where you come from, right? It's just going to give you a lot more problems. Okay, so now, let's say in the Scandinavians, that means the Swedens and so on, what is the animal that's supposed to bring the babies to the family?
The stork.
Yeah, the stork. Stork brings babies to the family, right? So they actually did a study looking at childbirth versus the number of stork flying across the village or what. And it's actually correlated. Does it mean that stork actually bring babies to the family? No, right? Okay. So the same thing, just going to use this again. Okay, we actually have a graph. Okay, so this graph is by month. So January, February, March, April, May, June, July, August, September, October, November, December. Okay. So we have two lines. This line and another line that looks like this. When you see two lines like this, do you think that they're correlated? So this is the number.
Teacher, we can't see any lines.
Oh, yeah. Hold on. Okay, so this diagram below. Okay. So when you see these two lines kind of overlap or the trend is similar, do you think that they're correlated? Do you think these two data sets are correlated by months?
Yes.
Yes, right? Correlated. And what if I tell you that the red line and the black line, the red line is the number of shark attacks. The black line is the number of ice cream sales. And this is actually a true data. Does it mean that the more ice cream sales is, the more shark attacks you're going to have? It's correlated, right? Or when after you eat ice cream, you are more delicious to the shark because then you have more calories and more fat for the shark to eat. So what do you think is happening? Look at the months. When is the time whereby you have the most ice cream sales? It actually correlates with these other summer months. And summer is also the same time for Western countries or for Northern Hemisphere. People go to the beach as well. So you are in the same place where you eat ice cream and for shark attacks. Okay, so hardly any people go to beach in December where it's so cold. Okay, so that's why correlation doesn't equal causation. And I want to show you this website, which is quite interesting. You can type this thing called spurious correlation. Look at this. Okay, the US spending on science, technology, science, space, science and technology is actually very well correlated with suicide by hanging, strangulation, and suffocation. The correlation is 0.997. So we should not spend money on science because it causes people to die by hanging. Okay. Anybody know who is Nicolas Cage?
He's an actor.
Yeah, the actor,
The
right?
National Treasure, the
Yeah,
protagonist.
right, National Treasure. Nicolas Cage. Cage. Yeah, the one that acted National Treasure. Yep, this guy. Okay. So, the number of people who drown by falling into a pool is actually correlate to the number of films Nicolas Cage appear in. Okay. And you have more. Per capita means how much cheese, on average, how much cheese the population consume per person is also very well correlated, about 0.95, to the number of people who die by being entangled in their bed sheets. Yeah, people do die by wrapping themselves like a burrito and die. Okay. So divorce rate in Maine is actually a northeastern state in America, very near Canada. Is correlated with how much margarine people consume. Look at the correlation, it's 0.99. Okay. Age of Miss America versus murder by steam hot objects, and so on. Do I still have one more Nicolas Cage? No. This is quite good, quite interesting. Number of winning letters, the number of the letters of winning words in the script spelling bee competition correlates with the number of people killed by spiders. So this is just to tell you that anything can be correlated. It doesn't mean anything. Okay? It's only in experiment that we can show that there is a causation. Very important, correlation doesn't equal to causation. Okay? A lot of alternate fake media like to use correlation equals causation. No, it's not. Okay, so that is what I'm trying to say. Okay, any other questions?
Yeah.
Teacher, can I ask that? Oh.
Yeah.
You go first.
Yeah. Okay, quick, Avina. Who?
For the Pearson formula, right, must we memorize because our the formula sheet don't have the formula.
No, you don't have to memorize. You don't have to memorize. Just
okay, thank you.
Yeah, Shanny.
Just so regression is basically the best fit line, is it?
Correct.
Okay, thank you.
Okay, any others? Okay, if not, then that's all for today. Have fun. See you on Tuesday. Bye-bye.
Thank you, bye.
Okay.
Thank you, bye.
Bye.
Thank you.
Maybe.